All right, today we're going to kind of change gears a little bit and work with solving polynomial equations. And we probably need to talk about this word polynomial right off the bat because you need to know this word and know what we mean by a polynomial. A polynomial is one that is kind of in this form, ax to the n plus bx to the n minus 1 plus cx to the n minus 2 plus ... d. And I know that looks scary, but if you pay attention to what's going on, what we're talking about is decreasing powers of x all the way down to just a number without an x. That's what we mean by a polynomial. Okay, this right here, by definition, is a polynomial. And what I want you to notice is that you've got several algebra terms together, all right? And, maybe a classic example would be something like 5x to the third minus 2x squared plus 5x minus 12. That is a polynomial, okay? So here's another question. Is a quadratic that we've been working with, is that a polynomial? Sure is. That would be another example, one of our good old-fashioned quadratics, negative 3x squared minus 5x plus 9. That is also a polynomial, okay? Technically, even a linear is a polynomial, 3x minus 4. But we usually don't call them linears. We don't usually call linears polynomials, but by definition it is one. Okay? And we don't normally call quadratics polynomials, but by definition they are one. Okay? So polynomial is a big term that talks about anything in this format up here. All right? So we're going to work with, I guess you would call it, some more advanced solving techniques. And the very first thing I want to give you is an important formula for factoring the sum or difference of two cubes. Factoring the sum or difference of two cubes. We've learned how to factor the difference of two squares, but not the difference of two cubes. So here's the first formula. If I have a cubed minus b cubed, if you follow this formula, it will tell you how to factor it. It will factor into a minus b times a squared plus ab plus b squared. All right? And let's leave a space, because I'm going to put a little quick example below each one. And if I have a cubed plus b cubed, it is exactly the same, but with a sign change. Okay? This is a plus b, and then this is a minus ab plus b squared. Those are the only differences.
Is it a squared?
Okay? Yeah, it is an a squared. Thank you. So they are exactly the same, but just a couple sign changes. So let's do a simple example. Let's say that I had x cubed minus 27. Does everybody recognize that that is the difference of two perfect cubes? That's why I had you get your root sheet out. Isn't 3 cubed 27? Right? 3 cubed is 27. So we just follow the formula. X minus, the b is going to be the cube root of 27. It's going to be the 3. So I'm going to put the 3 here. Times x squared plus a times b, so that will be 3x, plus the b squared, the 3 squared. So that's obviously going to become 9. And there it is, it's factored. Okay? So that's how we use these formulas, and I could do the same thing with the sum of two cubes. So what if, let's go straight to an example where we're solving an equation like that, like x cubed plus 343 equals 0. Now this is why I had you get your root sheet out, because you have to be able to recognize perfect cubes. Isn't 343 a perfect cube? 7, right? So we are going to use the sum formula. So x cubed plus, isn't it, it's 7 cubed, is the same thing as x plus 7 times x squared minus 7x plus 49. Now, technically I should have left myself some more space because we are solving an equation equal to 0, right? So for the sake of space here, I'm just going to take this out and I'm going to put a 0 there. We are solving an equation, so this thing is equal to 0. Now, remember those rules we learned about the zero product property that allows me to split this up? Now I can use that, okay, now that I've got it factored. So the first one is easy, x plus 7 equals 0, right? Solve that. X equals negative 7. Now the next thing I'm going to tell you a little hint. This thing over here, this quadratic, when I set this equal to 0, it will never factor. You're going to have to use quadratic formula. Okay? So anytime you're doing these sum or difference of cubes problems, this little piece over here, you're going to have to use the quadratic formula every time. Okay? So let me see if I've got room over here to do that. X equals negative b, so that's going to be positive 7, plus or minus the square root of b squared, so that's going to be 49, minus 4 times 1 times 49, all over 2a. So it looks like to me I have a negative discriminant, don't I? Don't I have a negative discriminant? So for this part, there's no real solutions. Okay, the only solution is negative 7. Okay, this right here is the only solution to that cubic. Will it always work out that way? No. Because if it is a cubic, okay, if it is a cubic, it has the potential to hit the x-axis 3 times. Okay? So there are no real solutions, but there are imaginary ones. So let's go ahead and finish this and find out what the imaginary solutions are. Let's see, 4 times 49 is 196. So I'm going to have the square root of 49 minus 196. And then I've got a 7 plus or minus all over 2. 7 plus or minus all over 2. 49 minus 196. Anybody done that on the calculator yet? Square root of... So that is going to become negative... Sorry about that. Negative 147 under there. 7 plus or minus all over 2. If I take my I out, then I have 7 plus or minus I times the square root of 147, which is the same thing as 49 times 3. Okay, use your root sheets. Use your root sheets to look for those perfect squares. So this is the square root of 49. This is the square root of 3. We're still over 2. So this would be 7 plus or minus 7 radical 3 I all over 2. I don't see any need to take out the 7 because there's no factors of 7 in the bottom. So there's my imaginary solutions to that polynomial. All right. So that sum and difference of cubes, you're going to use it a lot. I don't always do this, but I'm going to give you some wisdom here. You're going to use it on problems 4, 5, 6, 11, 12, 17, 18, at least on those, and maybe some others. Now, you're not doing odds and evens, but we'll probably have a practice day in there someplace. So you're going to use this sum and difference of cubes quite a bit in the next couple days. Now let's get to some other examples where we're not needing to use that. What if I have 3x to the 4th equals 48x squared? Now remember what we're doing. We're solving an equation. So the first thing we should try to do is to get this set equal to 0. So let's subtract 48x squared from both sides. And now I have 3x to the 4th minus 48x squared equals 0. You should always try to factor if you can. Now, right now, I've got two terms, okay? I've got a minus sign. So I'm thinking, could this possibly be a difference of two squares some way? Well, do you see there's a 3x squared in both of these? Let's pull out a 3x squared. If I do that, I'm left with x squared minus 16. And what do you know about that? We do have a difference of two squares. So I can break this up into 3x squared equals 0 and x squared minus 16 equals 0. So on the left side, I divide both sides by 3, and I have x squared equals 0, so x just equals 0. There's one of my solutions. Okay? And over here, I would factor this into a difference of two squares, x plus 4x minus 4. Split that up. Two new little equations. So we can see that x is going to equal negative 4 and x is going to equal positive 4. I want you to keep in mind the graphical meaning of those solutions. Okay? The fact that I have 1, 2, 3 solutions means that the graph of this thing, whatever this function is, would hit the x-axis in 1, 2, 3 places. Okay, whatever those three numbers, well in this case I put the x's in the wrong spot, but I'd have one at 4. Let me just mark out this. I would have one at 4, I would have one at 0, and I would have one over here at negative 4. Whatever that graph looks like. Okay? So keep that in mind. Let's move on. We've got a couple other situations we need to hit. What if I have this one? X cubed minus 3x squared plus 3x minus 9 equals 0. If I see 4 terms in a polynomial, automatically I'm thinking I need to try to factor it by parts. Okay? So it's just like when we do the product sum method for quadratics. I'm going to look at these two and these two. What is common to these first two? Looks like an x squared. So if I pull out an x squared, I'm going to have an x minus 3. And then in the second two, I have a 3, so it's going to be plus 3 times x minus 3 equals 0. And now I think you know where to go from there. This is now x squared plus 3 times x minus 3 equals 0. And we have got it factored. So now we're ready to split it up into 2. So I'm going to have x squared plus 3 equals 0 and x minus 3 equals 0. Obviously, this thing over here is easy on the right-hand side. There's one solution. We've got x equals 3. On the left, though, there should be some light bulbs going on. If I try to extract the square on this one, I have x squared equals negative 3. And if I take the square root of both sides, then I have that x equals the square root of a negative, so I need to take an I out. So x equals plus or minus radical 3 I on that one. A couple imaginary solutions on that problem. All right. Lots of different situations. I'm trying to get you ready for as many of them as I can. What if I have the square root of 2x plus 7 minus x equals 2? Like I said, these are more advanced solving equations than what we've done. So we're trying to put together several skills all at once. What do you think we should do first? You've got a radical, so aren't you thinking I'm going to have to square this at some point, right? If I'm thinking I want to square it, it would make much more sense to take this over, take that x over first before you square it. Because otherwise it will become really, really ugly. We want to isolate the radical if we can. Okay, if we can, we want to isolate that radical. So I have the square root of 2x plus 7 equals x plus 2. Now, when I get ready to square this thing, okay, I'm going to square this side, and I'm going to square this side. Make sure you use either the square of a binomial shortcut or FOIL on that right-hand side. This thing right here is not equal to x squared plus 4. That's a great big frowny face. Okay, that's not x squared plus 4. This thing is x squared plus 4x plus 4. Make sure you don't make that mistake. On the left-hand side, the radical goes away, and I just have 2x plus 7. From there, it's a quadratic, and you should know what to do. I would get everything on one side. So I have 0 equals x squared plus 2x minus 3. I think that one will actually factor. X plus 3, x minus 1. Split it up. So x equals negative 3, x equals positive 1. All right? So, but from this point on, okay, after we got past here, it was just a quadratic. And you know all the ways we can solve a quadratic. How about this one? A lot of this is just showing you all of the tricks of the trade here. These are just a lot of mixed up, different types. You're really going to want to have your notes close by when you do this assignment. Well, what does that 2/3 power mean? And we've talked about that. If I have something to the 2/3, whatever that is, let's say that it's 27 to the 2/3. Doesn't that mean the cube root of 27 squared? Right? Well, let me just give you the shortcut here. We want to get rid of that power. So to do that, we are going to use the reciprocal power of that thing. And we're going to raise both sides to that reciprocal power. let's see how this works. I have x minus 4 to the 2/3. I'm going to raise both sides to the 3/2 power. Okay? Now, why do we do that? Well, watch. When I have a power to a power, like I do right here, power to a power, don't I multiply those two? So what is 2/3 times 3/2? 1. So it's cleared up the mess on the left side. So now I just have x minus 4, because this thing right here is equal to 1. So I just have x minus 4 on the left side. On the right side, we have to deal with this fraction exponent. So I have the square root of 25 cubed. Right? So what is the square root of 25? 5. So this is technically x minus 4 equals 5 cubed, which is x minus 4 equals 125. So it looks to me like when I add 4, x equals 129. Okay, I know we're getting through a lot here today, but I'm trying to just get you ready for the situations you're going to see. This is the last thing we're going to have time for. If you see an absolute value problem like this, what you're going to do is you're going to break it up into two equations. All right? So you're going to say x squared minus 3x equals negative 4x plus 6. So you set it up the way it is, and then you have to set it up with x squared minus 3x equal to this thing times negative 1. So this would become 4x minus 6. And then you're going to solve both of them. Okay? So if you run into an absolute value problem, that is the trick, is to set it up the way it is, and then set it up with the what's inside the absolute value equal to negative 1 times the other side. That comes back to something we learned way back in Algebra 1 when we were solving absolute value problems. If I had absolute value of 3x minus 2 equals 7, I would set it equal to 7, and then I would set it equal to negative 7. It's the same idea, clear back from Algebra 1. And we're going to stop there for today.